Code Explained says hi. Today we're going to build the snake game using vanilla JavaScript, and this is how our game will look like at the end. So you can see here we have the score and the highest score. This is the snake and this is the food. You can also see that the game didn't start by default. So to start the game you must first press one of the arrow keys. So if I press the down key here, the snake starts moving and the game starts. You can see now that the score is incremented when I eat the food, and if I bump into a wall we can see the game over screen here. So we have our current score and this is now the highest score, because the oldest highest score was 0. Now if I click on play again you can see that everything is reset, but now the highest score is 4. Now if I go and refresh the page, it still says 4 here for the highest score, and that's because we saved this to the local storage. Now what is the difference between this game, or what's special about this game? Because there are lots of games or tutorials about the snake game out there. Well, let me show you what is special about our game. Well, there's this known issue about the snake game, and it's concerning the snake movement. So let's say you're moving upward and then you want to go and make a fast turn. So you want to go to the left and then to the bottom but faster. So what everyone does is they go and press the arrow left key and then faster the down key here. So in that case you might think that the snake will go to the left and then to the bottom as expected, but that's not the case, because what's happening here is that the snake will go and bump into itself. So it's like it doesn't go to the left but directly it goes to the bottom, which makes the snake bump into itself and leads to a game over. Well, let's go now and see how I created this game and how to fix those issues. Well, before we start the tutorial, I just want you to know that I have made more than 110 slides for this video, because this part is going to be about the logic, and I want every beginner out there, every JavaScript beginner, to well understand what we're doing. So I want you to take some of your time to support the channel, so why not like the video and subscribe, or even thank me if you can. That's going to be a huge support for your channel and I will really appreciate that. So without further ado, let's start our tutorial. Well, now I'm going to talk about the basics about JavaScript game development, so using HTML5 canvas. And I'm gonna go and talk about how to draw something on the canvas, like a rectangle, how to move that rectangle around to make it like a real game. So if you already know this, you can feel free to go and use the timeline to go directly to where I actually talk about the logic about the game we're going to be creating. Well, let's start our tutorial. So to draw something, you need a drawing board and you need some tools like brushes. And in our case here, that drawing board is the HTML5 canvas and the tools are JavaScript. So to build a game in JavaScript, you need first the HTML5 canvas. So you want to create this in your HTML code, and then you can use an ID for your canvas to select it with JavaScript, and then you can draw on the canvas. Now if I create this code inside an HTML code and then run that on the browser, I'm going to get a blank page. Now if I go and set a width and height, I'm still going to get a blank page. So to see the canvas here, you'll need to go and use a border for your canvas. You can do that using CSS, or you can just go and use JavaScript by going and selecting your canvas using a method like getElementById, and then set that to a const. And then you can use the style property and then change the border to 1 pixel solid black, and that's going to show your canvas on the web page. Now the width of this canvas will be 400 pixels and its height is going to be 400 pixels. Now to draw on the canvas, we need to get a drawing context on the canvas. What a drawing context means is methods and properties. Methods are functions that we're going to use to draw something on the canvas, like a shape, a rectangle, a circle, etc. So these functions here in general need some properties of what you want to like draw. For example, if you want to draw a rectangle, you want to know where you want or the position of that rectangle. For example, you want its x position because this is the x-axis on our canvas. It starts at the top, like left corner, and then goes to the right. And also you want to know the y position of your rectangle. The y-axis here starts from the top left corner going down. So as we go down, y position increments, and as we go right, the x position increment. And also you need to know some properties that concern your shape. For example, if it's a rectangle, you want to know its width and its height. And if it's a circle, you want to know the radius. Also, you might need a different color with you want to fill your shape. For example, I want to fill this rectangle with a red color. So all these parameters must be like passed to a function that's going to come from the drawing context, and that's going to draw the shape you want on the canvas. And now to get that drawing context on the canvas, what you need to do is to use a method called getContext. So getContext here takes in a parameter. In most of the cases, you want to use 2D, especially when you're creating two-dimensional games. If you want to like make a three-dimensional game, you want to use WebGL. Well, because we're like playing here with just like rectangles, two-dimensional objects, we're going to stick with 2D. Now this context here, constant, is an object. If we take a look on that object, if we console log it, we're going to find a bunch of properties and methods. For example, here one of the properties we're going to be using is the fill style property, and that's simply a color. So this is black by default. So this is the color with you want to fill your shapes. Well, if you don't change this here and then you want to fill a rectangle, that rectangle is going to be filled with a black color. Also, we're going to use stroke style, and it's simply the color of the stroke. So whenever you want to like draw a stroke, it's going to be in black by default, unless you change this. Now also, one of the methods we're going to use here is rect or fill rect. So fill rect here is used to draw a rectangle and fill it at the same time. So we have again a bunch of methods here, but I'm not gonna talk about them all. We're just gonna use fill rect and stroke rect. Stroke rect is used to like just draw a rectangle, but it's not filled. We just draw its stroke. Now let's go and see how we can draw this rectangle here. So we wanna like change the fill style to red, because if you remember, it's black by default. And then I want to use the fill rect method here. You can see that we have parentheses here, so this is a function, a method. This is just a property. Now the fill rect method here expects 4 parameters. The first one is the x position of the rectangle, which is 200, then its y position, which is 100, and then its width, 100, and then 150 for the height. So these are the parameters or the arguments you want to pass into fill rect to actually draw a rectangle on the canvas. Now if you want to like draw a stroke over it, you want to use the stroke rect method. Again, stroke style is used to change the color of the stroke. Now stroke rect is like fill rect, it expects the same arguments. So the position of the stroke, x and y, and then its width, and then the height. If I run this code here, I'm gonna get a stroke over my old rectangle. Now you might think that this code here and this one here are related in some way, but they are not. This is separate from this one here. So fill rect is used to like draw a rectangle with a fill, and this one here is used to draw a rectangle with just a stroke. But because we have used the same positions here and the same width and height, this makes us think that this stroke rect is related to the fill rect. But if I, for example, go and set 0 here to stroke rect, you can see that the stroke here is drawn at the left with no fill, and this is our old rectangle with or filled with a red color. So this means whenever you want to draw a rectangle with a stroke, you can just use fill rect and stroke rect with the same position and the same height and width. Alright, that's great. Now we can go and draw a rectangle, but it's useless as long as it's not moving. Well, to move our rectangle, it's going to be simple. We just need to change its x or y position. For example, if I change the x position, like increment it by 1, you can see that the rectangle will be drawn on different position here. And if I do this faster, you can see that this creates an animation here. So it gives us the feeling like the rectangle is moving. This is shown in a flipbook animation here. Like this is just like a book, just pages. You know that every frame is just a single picture. But when you flip the book faster, you get this animation here. So that's exactly what's going to happen with our canvas. Now, if we want to move this to the bottom here, we need to change the y position. We need to increment the y position here. So as I increment in the y position, the rectangle is going down. If I increment both x and y, the rectangle will go diagonally. Now let's see how can we do this dynamically. So we need to go and create a function called frame. So this is like a single page in our flipbook animation. So this frame here is a function that we need to call every single time. So I'm going to change this fill rect x and y position to some variables. I'm going to call them x and y because that's what they are. And then here I'm going to set them to 0. I'm going to define them outside the function. And then here I want to keep incrementing the x by 1. So each time I call the function, x will be incremented by 1 and they will go and draw the rectangle in a different position than before. Well, then I need to use a method called setInterval. This is a built-in function in JavaScript. This function here takes in the function you want to call and the time here or the interval. So this is in milliseconds, 1000 is 1 second. This means that setInterval will call our function frame every 1 second. So if I run this code here, what I will see is my rectangle here moving to the left by 1 pixel every 1 second. But that's not what's going to happen if you run this code here. This is what's going to happen actually. So we will see the first frame here where we draw the rectangle, the first rectangle at position 1. And then on the second call, when we call the frame for the second time, we're going to see another rectangle here. And this is our old rectangle at the background here. Then on the third call, we're going to see another rectangle and so on. So the difference here is that for the computer, whenever we call frame, fill rect is like drawing a new rectangle. And for us, human, we think that this is the same rectangle. Well, that's the same rectangle, but for the computer, it's not the same rectangle. That's a different rectangle. Well, to fix this issue here, what we need to do is to think about our canvas like the flipbook here. So you can see here that on this page here, we have drawn our characters. But then on the second frame, the next frame, it's going to be like an empty page, and then we draw again from the start the characters again in a different position. This means for our canvas that we need to draw the rectangle, but then in the next frame we need to use a new page which means we need to clear the canvas, like we need to clear the whole thing, remove the old drawing, and then draw the new rectangle in a new position. So here I'm going to use a method called clear rect. This is used to clear a rectangle, and that rectangle here is going to be our canvas. So its position is 0, 0, so the top left corner here. So this is 0, 0, 0 for x and 0 for y. And then it's going to be the width of the canvas and then its height. So this rectangle here is our canvas, and that's why we use the canvas width and the canvas height. So this code here will clear this rectangle here that starts from the top left corner, and it has the width and the height of the canvas, which means we're going to clear the whole canvas, not just like a small area of the canvas. Well, if we run this code here, what's going to happen? First, I want to talk about something I did on purpose here. So if I do this code here in this order, what's going to happen is x is equal to 0, then x is going to be 1 here because we increment this by 1. Now when we draw the first rectangle here, it's going to be drawn not on the 0 position for x, but on the 1. So we're never going to see the rectangle drawn at this position here. So what we need to do is we need to swap these two codes here. So we need to go and draw the rectangle at 0, then increment 1. Then on the next frame, that's when we draw the rectangle on the position 1. So now what's going to happen here when we run this code here, we will call frame, we clear the canvas, even though it's already cleared, then we draw the rectangle on the first position here. Then we increment x by 1, then we call frame, we clear the canvas, we draw the rectangle on the new position, we increment x again, we clear the canvas, we draw the rectangle on the new position, then we increment x again, and so on. So if I do this faster, so if I go back here and do this faster, this will look like the rectangle is moving. Now you've seen that the animation here is not great, but that's because I'm doing this so slowly. So in our game, when setting this time or the interval, it's going to be so small, 15 times per second. That's going to be very fast. We will see that the animation is going to be so smooth. Now let's go and talk about the HTML code. So this is where we start talking about our game. Well, in the index.html file, we need to create a container for the game. Then we need to create a div with the class name current score to show the score, then also to show the high score, a div with the class name high score, then our canvas with the width and height of 400. Of course, we're not going to see these tiles yet, and we're not going to see the border. We need to set that using CSS or JavaScript. Then we need a game over screen, so we're going to use a div with the class name game over. But we use here a class name called hide, and this is in our style.css file. Hide is a class name used to hide an element. So whenever you add this hide to any of this element, this will hide that element. So we add this by default to this div here. So when we start the game over screen is not shown. Now inside the game over div, we have this div with the class name message to show the game over message, then the score, the current and high, and then the button play again to play again the game. That's all we need for the HTML code. And now from now on, we're going to talk about JavaScript. And now I want to talk about the game components, and they are the board, the snake, and the food. Well, the code for our game is going to be inside a file called game.js. And the first thing I want to create about these components here is their colors. So I have here the head color, and then the body color. They are different colors. And then the board color, which is going to be white, and then the food color. Well, I want to use these variables for colors because if some of you want to make a light mode and a dark mode for the game, he can simply go and change the colors of the components. Something I want to mention here is that the snake is made of squares or rectangles, and also the food is made of a square or rectangle. And here you can see that we have a stroke, and that stroke needs a color, but we didn't create it here because simply the stroke color for these squares and the food also is the same color as the board color. Now, there is no game without the game loop, and we need to create one for our game. So I'm going to create a function called frame, and then I want to use setInterval to call the frame function every FPS. So I call this FPS because it stands for frame per second. So how many times you want to call the function frame in a second? So it's gonna be 1000, which is 1 second divided by 15. And this means that I want to call the frame function 15 times every 1 second. So that's 15 frames per second. Now I want to set this to a variable called game loop, which is going to be a global variable so I can access it from anywhere in my code. Now why do we need this variable game loop, which is set to setInterval here? We need this variable because in some point we need to stop the game. So we need to stop this game loop here. And that's going to be when the snake hit a wall or hit itself. That's when we need to clear interval. This is another built-in function like setInterval. SetInterval is going to be used to start the loop, and clear interval is going to be used to stop that loop. And we must pass in the game loop here. And then we need to use game over to show the game over screen. Now frame needs to call drawBoard to draw board on every frame, draw food, and move snake. So we need to move snake on every frame. Then we need to draw the snake on every frame and also to render the score on every frame. Now let's go and talk about the logic behind these functions here, and the first one is going to be drawBoard. Well, to draw the board is to draw a rectangle that has the same dimensions of our canvas here. So I'm going to need the board color. This is the color width I want to fill the rectangle, our board. Then I'm going to create this function called drawBoard. Then inside I want to change the fill color to board color because by default it's black. Now this is the width and this is the height of the canvas, and also the width and the height of the board. So why not make them variables so I can use them later on in my code. So I'm going to set width to canvas width and height to canvas height. Then I can just use the fillRect method to create a rectangle or to draw a rectangle and fill it with this color here. So the rectangle width and height is going to be the same width and height of the canvas. Now let's talk about the position or the X and Y position of our board or this rectangle here. So our rectangle or the board will cover the whole canvas, which means that this point here is the X and Y position of our board. So again, this is the X axis and this is the Y axis. They both start from here. This is the origin of the X and Y axis. So this is 0 for X, and in the middle here is going to be 200 for X and then 400. Now this is again 0 for the Y position, and this is 400 pixels for the Y position. Now because our board is going to start from here, this is its position, so it's going to be 0 for X and 0 for Y. So I just need to put here 0, 0 for both X and Y position. And now when we call drawBoard function from within our frame function, we're not going to see any changes because the board color is the same as the background here of our page. So that doesn't mean that our code is not working. So we just need to change the board color to another color, for example black, and we can see now that the whole canvas is filled with black. And now I'm going to talk about one of the issues you will end up with when you're building the snake game. So when you use pixels here to draw your snake and the food, you will end up with this situation here a lot of times. And your snake here will never be able to eat the food because they are not aligned. They are not on the same line. So when someone is playing the game, so he must be very precise, like to put the snake on the same position in pixels with the food. So, and that's going to be hard to do or impossible. So what we're going to do here to fix the problem is we're going to make those pixels a lot bigger. So what I mean here is I'm going to consider my board as if it were made of these squares here rather than pixels. So simply I'm going to use a new unit to draw the snake and the food. So instead of using draw the food at 30 pixels from the left, I'm going to use squares. So I'm going to tell the computer to draw the food on the snake or any square, draw the square at 1, 2 squares from the left and 1, 2, 3, 4 squares from the top, and that's gonna make our food or any square always be drawn on a square exactly, never somewhere in between. And I'm going to achieve that by simply setting a square size, a const, to 20, and that's because this square here width is 20 and its height is also 20 pixels. So now instead of drawing my squares, I'm going to use the square size unit instead of pixels. And now I'm going to talk about two numbers that are going to be more useful to build our app, and that's going to be the number of squares we have horizontally and the number of squares we have vertically. And it's going to be calculated with this formula here. So I'm going to divide the width by the square size. So if I take 400 divided by 20, it's going to be 20. So this 20 here is this 20 here. So I'm going to get 20, a number. So it means that I have 20 squares horizontally, and the same thing is going to be for the vertical squares. They were going to be 20, and that's because the height is equal to 400. And now let's go and talk about how to draw a square. So I'm going to use a function called drawSquare, and now because we need to know the x and y position of the square we want to draw, so I must pass that as parameters to my drawSquare. Also, we need to know the color width we want to fill the square, so I must pass also that as a parameter. And because the stroke here color is the board color, I don't need to pass that as parameter because the board color here is a global variable that I can access from within my drawSquare function. So now all I need to do is to go inside the function and change the fill style to this color here, the one I want to fill with my square, and then change the stroke style to the bold color. Then use fill rect to draw the rectangle filled and stroke rect to draw the stroke. And now because we said that we're not going to use pixels to draw a rectangle here or this square, so instead of using 320 pixels for x and 300 pixels for y, I'm going to use the number of squares here. So I'm just going to go x is equal to 16 square sizes, or here for the top or the y position is going to be 15 squares. So now instead of using this unit pixels, I'm going to use square size. And you can see here that the numbers here are make more sense than 300 and 320. So now what I'm going to do is I'm going to create a const sq. I'm using two letters here just to get some space here, because if I use square size here, it's not gonna fit. So fill rect here needs an x and y position, so I'm going to pass x times square, 16 times square size, then y times square, then for the width of the square is going to be the same thing as square size here, 20 pixels, and the height is going to be 20 pixels also. Now I'm going to pass the same arguments for the stroke, so the stroke will always be for this rectangle here. And now to draw this square here, all I need to do is call the function draw square. I must pass in the x position, which is 16, and then 15 for the y position, and then the color blue, and it's gonna draw this square at this position here. So now when I read this code here, I'm going to say draw a square at 16 squares from the left and 15 squares from the top, and filled with a color blue. And now that we know how to draw a square, let's move and draw the snake. So the snake is made of 3 squares by default when the game starts. So the first square is at this position here, and that position is given by x 0 squares and y 0 squares. And then the next one is given by x1 square, so this one here has 1 square from the left and y 0 squares from the top. Now the last one, which is the head of the snake, is given by x2 squares from the left and 0 squares from the top for the y position. Now you can see here that every square of my snake is an object with 2 properties, the x and y position. Now I'm going to put this inside an array because all of these positions belong to the same thing, which is the snake, and I'm going to assign this to a variable called snake because snake here is going to be changing. That's why I used let here and not const. Now you can see here that this is the head and this is the body of the snake, and the last one is going to be the tail. So you always need to remember this. The first element is always going to be the head, and the last element is always going to be the tail of the snake. Now to draw the snake, we simply need to create a function called draw snake that we're going to call every frame from within our function frame, if you remember. And then I'm going to loop through my array here, snake, and then go and draw each of these squares. So I'm going to use a for each method that takes in a function. And then for each tile or square, I'm going to call draw square because each one here is just a square. Now I'm going to call this a tile, or I can just call it square actually, but I'm just going to stick with tile. And then I'm going to call here draw square with tile.x, the x position of that square, and then tile.y, the y position of that square, and then the color here. But the color here depends on whether we draw the snake head or the body. So I'm going to check if the tile we're drawing here is the head or the body. So for that, I'm going to use the index. So the second parameter we pass into our callback function here is the index. The index of the first one is 0, of course. This one is 1, and this one here is 2. So I'm going to check if I equals 0, if the index is 0, so that's the head. So I'm going to use the head color as the color I'm going to fill with this square. And then if it's not, I'm going to use the body color. So here it's going to be head color for the square. Here it's going to be the body color, and here also it's going to be the body color. So that's how we can draw the snake. And now that we have drawn the snake, it's time to move the snake. So the snake can move either to the top, bottom, right, or left. And that's going to be based on the user's clicked or pressed key. So we need to listen to the user's key press using an event listener. Well, let's go first and talk about how can we move the snake. So I'm going to use a variable called direction or current direction, and this is going to be changed whenever the user clicks on one of the or press one of the arrows. So if it presses the arrow up, I'm going to set current direction arrow up, and the snake will move to the top. How? So this is our snake array. It has 3 squares. This is the head and this is the tail. Now I'm going to get the head because the head is going now to the top, and I just need to move the head from this position to this position here, which means I need to get the snake with index 0, that's the head. And now because if I just set head to snake 0, I'm not creating a new head or a new object. I'm creating a reference to this object. So if, for example, I change head.x or head.y, that's gonna change this object here inside the array. And that is something we don't want to happen. So I'm going to spread this object here and then put it a new object. So I'm creating here a new object with these same properties by spreading this object. Now this head will be equal to an object with x and y, 15, 5, but doesn't relate to this one here, or doesn't have any reference or any connection to this one. So now to move the snake to the top, I need to decrement y by 1 square, or if I want to move it down, I want to increment y by 1 square without changing the x position. Then if I want to go to the right, I want to increment the x position by 1 square without changing the y position. And then if I want to go to the left, I just need to decrement x by 1. So here, because I want to go to the top, I'm just going to go and get the head.y and then increment it by or decrement it by 1. So this is the resulting object. X is 15, not changed, and y is going to be now equal to 4 after we subtract 1 from the old y position. Now, if I just add this head in my array and then draw the snake, it's going to be having 4 for the length, or 4 squares. So what we need here after we add this square here, the next square or the new head square in here, we need to remove the tail. So I'm going to use pop, and pop is used to remove the last element in an array. So if I run snake.pop, this will remove this object here, and that's going to remove the last square here, and now it's time to add this new here into its place. So for that, I'm going to use unshift. Unshift is the opposite of push. Push is used to add elements to the last or to the end of the array, and unshift is used to add elements to the start of the array. So if I unshift head, this will add this object into into the start of the snake array. And when I run or draw the snake on the next frame, this will draw the head in the new position. So now you can see here, this is the old snake array. You can see that the tail is not there anymore. It's removed by the pop method. Now the old body is now the tail. The old head is now in the body, and we have created a new head in the new position. So that's how we move the snake. So what we need to do now is we need to listen to the user's key press. I'm going to add an event listener to document, which is a key up, and then I'm going to run a set direction function. Then I'm going to create a current direction variable, which is set to an empty string or when the game starts. That means that the snake isn't moving anywhere because current direction is not set to any direction. And then set direction here is going to be a function. Add event listener will pass a parameter to the set direction. The first parameter is going to be the event itself, the key up event. The event here has a property called key, and it's going to be arrow left or arrow right or arrow up or arrow down for these arrows here. So now I have used these inside an object called direction. So now if I want to refer to arrow left, I just need to say direction.left. And this has a lot of perks. So for example, I don't want to go and type in these strings all the time in my code. I can make a typo. And for example, later on, if I want to change these to numbers, for example, because I can use e.keycode. If I want to change this to numbers, I want to go through my whole code and change them one by one. So I prefer to put them inside an object here. So to refer to them, I just need direction to the left, and whenever I want to change them, I will change them just in this place here. Now I'm going to set this to a constant called new direction. So I have a current direction and I have a new direction. And then I'm going to set the current direction to the new direction. Well, here I use new direction just to make my code more readable. Now with this simple code here, our snake will move just fine, except we have two issues that we're going to discuss in the next slides. Now, the first issue with this code here is when the snake is going to the top and you press down, the snake will change to the opposite direction. Same thing when going to the right and press left, the snake will go to the opposite direction right away. And that's not okay. So what we need to do here is we need to go and create another const that I'm gonna call old direction, which is gonna be the current direction. So if for example here, if the new direction is left, if the user wants to go to the left, I want first to check if the old direction is not right. So if that's true, then I'm going to set the current direction to the new direction, which is going to be in this case left. So I only want to go left if the old direction is not right. So for example, if it was up or down, then I can go to the left. Or the snake can go right if the old direction is not left. Or the snake can go up if the old direction is not down. Or the snake can go down if the old direction is not up. So if one of these conditions here true, then we can go to that direction, and this will fix that issue. Now let's go to the next issue with the movement of the snake. And now let's talk about the second issue. So this is the issue we talked about in the start of this tutorial. So let's say the snake is moving to the top and then the user presses left and then down faster. So what happens here is the snake will not move to the left, it's going to move up then down directly, which is going to lead to a game over. So you might think that the code here isn't working. So let's check that. So when the snake is going up, so the old direction is arrow up. Then when he presses the left key here, then the new direction is arrow left. Now we're going to the if statement. So the new direction is left, but the old direction is not right. And that's true. So it's arrow up. So this is true. And we don't need even to go and check these here because this is an OR operator. So this is true. Then we set the current direction to the arrow left. Now then the user presses arrow down. So the new direction now is arrow down. The old direction is arrow left. Now again, new direction equals direction that down, arrow down. Then the old direction is not up, it's arrow left. So this is true. Then we set the current direction to arrow down. So you can see that this code here works very well. So the problem comes from the FPS, the time we take to render the next frame. The time we take to render the next frame is actually very long compared to how fast the user was to press these two keys. So when the user pressed the left key, that didn't get rendered, and the user pressed the arrow down faster, and that's when the frame get rendered. So we don't see the left key rendered, but just the down key rendered, and that's what causing that issue. So what we need to do here is we need to take care of every pressed key. So we need to save these keys, the pressed keys by the user, and then we make sure that on every frame the direction is served. So what I'm going to do here is I'm going to go and create an array called directions queue. So this is where I will save all the keys pressed by the user. And then from this directions queue, I'm going to consume each or every direction one by one and set them the current direction to go or to move in that direction. So now after this test here, instead of setting the current direction directly to the new direction, I'm going to save first that new direction in my directions queue. And now all I need to do is I want to make sure that every direction here in my directions queue get consumed on every frame. So now if the user has pressed the arrow left and the arrow down fast, so now the arrow left and arrow down are both going to be saved in our directions queue. Now again, I just need to go into my move function, move snake function. That's going to be called on every frame, and then consume this one here. Then on the next frame, consume this one here. So let's go and see how I can do that. So I have my function move snake. If you don't remember, move snake is being called from within my frame function. And that's how now I know that my directions now will be consumed on every frame. So no frame is going to be skipped. So, or no direction will be skipped. So I'm going to go now. So I'm just going to go like and minimize this code here, my switch code here. So if you don't remember this, this is where we like get the current direction. If it's arrow left, we decrement x by 1 square. If it's right, we increment x by 1 square. Up, we decrement 1 by 1 square, etc. And then after we like changes the head position, we just pop the tail and then unshift the new head. So we've seen this before. We didn't just talk that this is gonna go into the move snake function. Now all I need to do is now consume these directions here. So here I just need to like get these direction first. So you might say that I want to like say directions queue with index 0. That's how I can get this directions or this direction here. And then based on that direction, I'm going to move the snake. Yeah, that's gonna be okay. But I need, after consuming that direction, I need to remove it. So I need another line here to remove that direction or that element from the array. So here what I need to do simply is use a method called shift. That's the opposite of pop. So pop will remove the last element and return it. Shift will remove the first element and return it. So now I'm gonna go here and get arrow left set to current direction and also remove arrow left from the directions queue. So what's gonna happen here on the first frame, we're going to consume arrow left. So I'm going to set current direction to left, remove it from the directions queue. So switch will do its work to position the new head in the right position, pop the old tail, and then move the snake head to the new position. Then on the next frame, we're going to consume arrow down. Then the current direction now is going to be arrow down, pop, and shift, and that's going to move our snake in this position here. And now on the next frame, now the directions queue is now empty. If I go and use directions queue.shift, current direction here is going to be set to undefined. Switch will not switch to any direction, and then we're going to pop the tail here. So we're going to remove this one here, but we're not changing the head, so we're not moving this one here. And the next frame, that's the same thing that's going to happen. So the snake will keep shrinking till it's 1 square. But we're not going to get to that. We're going to receive a game over. Don't care about what I said right now. So what I mean here is that we need to make sure that we don't run this code when the directions queue is empty. So when there's no direction in the queue, we just need to skip this code here so we can save the old direction. So I just need to check if the directions queue is not empty here, then we consume the direction. So I'm going to check if directions queue.length. So if this is empty, this is going to be 0. So that's false. So we're not going to run this. If this has at least one element, directions.length is going to be equal to 1. 1 is true. So we're going to run this code here. And that's how we fix the second issue about the movement of the snake. Now it's time to create the food. So I'm going to create a function called createFood that will simply return an object with two properties x and y that determines the x position and the y position of the food. So then I can use draw square with these two values to draw the square in the right place or position. Now when the snake eats the food, we need to generate a new x and y position. This means that we need to randomly generate these positions here. Of course, these positions here are given using squares, so this is one square from the left and two squares from the top. So when creating the food or randomly generating the food position, we need to take in mind something. So we need to know that the list or the minimum y position of the food must be 0 and the maximum position of the food must be 19. So we're going to talk about that in a minute. So we have here 20 squares horizontally and the last one's y position is 19. So the same thing for the x position, the minimum x position must be 0 and the maximum x position must be 19. This is the x position here, not the last end of the square. Now I will create a function called createFood that will return the food, which is simply an object with two properties x and y. Then I'm going to use math.random, and math.random will generate numbers between 0 and 0.999, like 16 nines. So you can see here that math.random will return 0 included, but 1 is not included. So we just get 0 and numbers less than 1. So I'm going to use math.random. Now let's keep it just at 0 and 0.99. And now I'm going to use horizontal square and vertical square. So this is where these two constants we created before are useful. So now I'm going to multiply this by horizontal square, which is 20, and the same thing here, I'm going to multiply this by vertical squares, which is also 20. So if I do this here, you can see that I'm going to get 0 and 19.8. Now let's go back here and see the last position here, x position of the square, and it's going to be 19. So this one here is 0. The second one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you can see that the last square here, the 20th square, has the position or the x position 19. So this means that if I draw the square at 19.8, that's going to be off the screen here or off the canvas. So what we need to do here is we need to round this down to 19 by using math.floor. So if we use math.floor, then we pass in, for example, 5.9, this will return 5. Math.floor of 5.1 will also return 5. So this will solve the problem, and now I'm gonna get our numbers between 0 and 19. So now I will be sure that all the generated food x and y positions will be inside the canvas. Now, one problem that can happen when generating this randomly is the food position will be drawn on the snake, and that's because the food position generated randomly will have the same position as one of the squares in the snake. So what we need here to fix the problem, whenever we create a new food, we need to check if the snake array, so we need to go through the snake squares and check if one of them has the same position as the food or not. If it doesn't have the same position, we then go and draw the food. If it's not, we need to regenerate a new position for the food. Well, to do this, I'm going to use a method called array.sum. I have a separate video if you want to check that. Now, I'm just going to do a simple example here. So let's say we have an array of numbers 1, 2, minus 3, 4, 5. Now what I'm going to do is I'm going to call sum on my numbers array, and in general sum takes in a callback function. The first parameter of the callback function is going to be the elements of my array. I'm going to call this number. Then what I need to do is to return a condition. When this condition here evaluates to true for at least one of these numbers or elements, sum will return true. But if this condition here evaluates to false for all the elements in my array, then sum will return false. Well, something that's useful if you have an arrow function that only returns a value, you can just get rid of these curly braces and the return statement. Now let's do an example with our numbers array. So I'm going to check if some number in my numbers array is negative. So what will happen here, sum will go and run this condition on 1. You can see 1 is not less than 0, so that's going to be false. Then it's going to go to the next one here, 2 is not less than 0, false. Then minus 3 is less than 0, so this will return true. Now sum will exit and return true. So this means that at least one of the numbers in my array is negative. So if I have, for example, all the numbers positive here, sum will go through them one by one. They are going to return false, and sum at the end will return false. So you can see here that the array sum will work great for our problem here. So what I'm going to do here is I'm going to check here if the snake.sum or sum square of my snake array has the same position, x and y position, as the food here we just generated here. If that's true, I need to regenerate a new food using the same code here. But again, if I regenerate a new position for the food, that can also be having the same position as one of the tiles, which means I want to keep regenerating the food position while this is true. So I need to use a while statement here. So while the snake or while sum of the squares of the snake has the same position as the food, regenerate a new food. When this is false, then we return food and withdraw the food on the next frame. So that's how we can create the food. Now to draw the food, we simply create a function draw food and we use draw square inside. So I'm going just to use food.x and then food.y positions because food here is a global variable. And then I need to use the food color, of course. So that's how we can create the food and how to draw the food. And now let's talk about what's going to happen when the snake eats the food. So when the snake eats the food, we need to increment the length of the snake by 1 square. So we will simply not use snake.pop. So if we use move snake, if we call move snake without snake.pop, this will keep just unshifting the new head, which means adding a new square to the start of the snake here. So if we don't use pop, we don't remove the tail, and we just keep adding a new square to the start of the snake, and this will add more squares to the snake, and the snake will get bigger on each frame. So we're going to use this idea when the snake eats the food. So we will check if the snake has eaten the food, and if that's true, we don't need to pop the tail. But if it didn't eat the food, we need to keep popping the tail. So what we need here to do is we need to use an if else statement. So if the snake has eaten the food, we need to go and regenerate a new position for the food. And this will make the food drawn in a new position. And then we go directly and unshift the head without popping like the tail here, which means the snake will get bigger by 1 square whenever it eats the food. But in the other case, when this is false, so if the snake didn't eat the food, what we need to do is we need to keep using pop to remove the tail. So the snake will always keep its length. Now let's talk about has eaten food. We will need simply to go and get the head, because the head is what we use to eat the food. So then we simply need to check on every frame if this square here, the head, has the same position as the food. So we need just to compare their x position and y position. So I'm just going and use food.x equals head.x and also food.y equals head.y. and I will just return directly this condition here. And that's it for has eaten food function. And now it's time to implement some collision detection for our game. So we need to check when the snake hits the wall or it hits itself. So here, when the snake touches the top wall, it's not a game over. So when the Y position of the head is equal to 0, that's not a game over. So also when X position here is equal to 0, that's not also a game over. When X here equals to 19, that's not also a game over. Also when Y position of the head is 19, that's not also a game over. So it's a game over when the snake X position is less than 0 here. So I only need to check the X and Y position of the head to check if the snake hit the wall or not. So I'm going to create a const called head, which is equal to snake with index 0. Now if the head.x is less than 0, that's a game over. Or if the X is greater than or equal to 20. So if it's 19, it's not a game over. But if it's 20 or more, that's a game over. 20 here is just the number of horizontal squares. Then also, or if Y position is less than 0, that's a game over. Or if the Y position is greater than or equal to 20, which is the number of the squares vertically. So if head.y is greater than vertical squares, that's going to be like game over. Now when one of these statements here is true, this whole thing will evaluate to true and we will end the game. So I'm just going to return the whole statement here and put this inside a function called hitWall. HitWall is going to be called on each frame. So in each frame, I'm going to check if the snake hits the wall or not. When this returns true, I need to stop the game. Now let's go and check if the snake hit itself or not. So we need to check the head against the body of the snake. So if the head position happens to be the same as one of the body squares position, that's a game over. So we need here to separate the head from the body because we don't need to check the head against the head. So what I mean here, I need to go and create a snake body array and then the head, which is going to be an object. So snake body is going to be just our snake array without the body. Because I'm going to change the snake body here, I don't need to set equal to snake because this will create just a reference to our snake. So if I change this here, I will change the original array snake. So I'm just going to spread again the snake, then put it inside an array, and that's how I create a copy of the whole snake array. Now the snake body here is going to be equal, for example, to an array like this, where we have here the head and this is the tail. Now we need to remove the head and save it inside this const because we don't need again to check the head against the head because that's always going to be returning true. So this will look like the snake is always hitting itself. So here I will need to go and take this snake body, which is just a copy of the snake, not the original array, and use shift. If you remember shift, we remove the first element and return it. So this is how I will remove that from the array. So now the snake array is just the body of the snake. And also here I got the head saved inside this const here. Now all I need to do is use the sum method, and check if one of the tiles, these tiles here, of the snake body is the same or has the same position as the head position. So if the tile.x is equal to head.x and tile.y is equal to head.y. If this is true, this means that the head has the same position as one of the body's squares. So I'm just going to return this statement. Then if this evaluates to true, the snake hit itself, we need to stop the game. If this returns false, the snake didn't hit itself, we need to keep playing the game. So hit self, also like hit wall, will be called on each frame. And that's all we need for the collision detection for our game. Now it's time to show the score to the user. So whenever the snake eats the food, we need to increment this by 1. So I'm going to create a score variable and I'm going to set it to 0 when the game starts. So you might think that I'm going to increment score whenever the snake eats the food. I'm not going to do it that way. That's going to work, but I'm not going to do it that way. I prefer to use the snake length because the snake length increments by 1 every time the snake eats the food. So I'm going to set the score equals to snake.length. And because the snake here starts with 3 squares, 3 elements in the array, the snake length is going to be 3, so the score is going to be 3 when the game started and the user didn't yet move the snake. So what we need here, I need to go and use a const initial snake length. So I need to know the initial snake length when the game started. So this is 3 here because we have here 1, 2, 3. And now to calculate the score, I always need to subtract that initial snake length from the snake length. So here 3 minus 3 is going to be 0, and we will show 0 here. When the snake eats a food, it will increment by 1. Now the length is 4, 4 minus 1, that's going to be 1. So we'll see 1 here. Now this code here will run on every frame. That's because this code goes inside our function render score. Now render score will run on every frame, but this code here will run only when the game starts. So that's how I keep initial snake length set to the initial length of the snake. Now let's talk about the high score. The high score is going to be calculated when it's a game over. So I always need to compare high score against the score. If this score is higher than the high score, the score will be the new high score. If the high score is higher than the score, then we keep the old high score. So when the game starts, I want to set the high score to 0. Now let's see an example. So here the score is 1. Let's say the game ends here. This is a game over. Then I want to use math.max. Math.max will return the highest of these 2 values here. So high score is 0. The score is 1. The highest one is score. So now this will return 1. And I'm going to assign this to the high score. So I will always run this code here when it's a game over. So I always want to check what is the highest value of these 2 values here. Now we run this code on the game over and we show that a high score to the user here, but also when the user refreshes the page or play again the game, we need to go and update this one here. Or if the user closes the game and then opens the game again in the next day, we need to keep or to save the highest score here. So how do I save the highest score? I will use the local storage. So I want to use the setItem method of the local storage object, which takes in 2 parameters, the key and the value you want to save. For the key, you can use any key you want. I'm going to use high score. This key is used or provided whenever you want to get the item back from the local storage. And then the value I want to save is the high score. So these 2 lines here must be run or must be called whenever it's a game over. Now that I have saved this to the local storage, let's say again that the user closed the game and opens the game again. So we saved the game, but when the game starts, the high score is 0, so I'm going to say 0 here, which means when the game starts, I need to get back that item I saved to the local storage from the local storage. So here I'm going to set the high score to local storage.getItem, and I need to provide this key here. Now let's say that this is the first time the user is playing our game, which means we didn't save nothing to the local storage yet, because we only set or save the high score to the local storage when it's a game over, and this is the first time the user is playing the game. So here I need to check if this is false. If this is false, I'm going to set this equal to 0. But if this is true, I'm going to set whatever was saved in the local storage to the high score. So I'm using here OR. Now what this means is when when there is nothing in the local storage with this key here, this will return undefined, and undefined is false. So OR will go and check what's on the right here, and then we run this code. So 0 now is assigned to high score. But when this is true, we will assign this to high score without going to check this one here, because true or false will always be true. So no need to go here. That's how the OR logical operator works. And that's how we can save and get the high score from the local storage. And now it's time to talk about how to show the game over screen. Because if you remember, in the HTML part, we added this class name hide that hides the element game over. Now all we need to do when the game over state is achieved, we need to remove this hide using JavaScript, this hide class name. So simply we need to go and select this element here, the game over element, using its class name. And then all I need is to use the class list object of our element and then use a method called remove. This method here is used to remove the class name from the class list of this element here. So I need to provide the hide class name, and this will remove hide. So we will show the game over screen. Now, when it's a game over, the user can play again the game by clicking on the play again button, which means we need to go and add an event listener to this button here. And when the user clicks on this one here, on this button, we need to hide this screen here, and we need to reset some variables of our game. So the first thing I will reset is the current direction. I'm going to set it to an empty string again, so we don't need to start the movement of the snake right away. Also, we need to empty the directions queue, and then we need to reset the snake to its start size. So I just used here one single square. You can use whatever you want. And then I will hide again the game screen by adding the hide class name to the class list of the game over element. Then I will need to start the game loop again by calling set interval, because when it's a game over, we use clear interval passing game loop to stop the game. And that's all with how we play again the game. Well, I think this was the last slide in this part, the part about the logic behind the snake game. In the next part, I'm going to code the snake game using all we've seen in this part. So don't forget to like, comment, share, and subscribe, and stay tuned.